Okay, so what JMS is? JMS is an application program interface from Sun Microsystem that supports the formal communication known as messaging between computers in a network. It means that if you want to send a message to some other application, then you can use this JMS API. So what it actually does is it will send this message to a queue, and someone else can listen to that queue and they can receive these messages, right? So how it can be useful? So an application, it just delivers a message to a JMS. So JMS, so there must be a server in your network, either IBM MQ or Active MQ అనేది so message broker అంటారు. So message broker means it's a server that actually receives all your messages and delivers it to the particular destination. So here we have message consumers and message producers. Message producers are those who send the message to this queue, which is on the JMS broker, like on the server, and someone who registers to this particular queue, they can consume the messages once it arrives in this queue. So what is the advantage of using this JMS? Like what is the advantage of delivering messages and consuming messages? So if you are on a network and you want to send some XML file to a system that is, um, let's say you written a program in .NET or some other mainframes program, so it can just register to this particular destination or this queue name, and whenever some message delivers or XML delivers, you can deliver it from a Java class itself. So you can deliver a message, XML message, and whoever registers to this particular queue, they can listen to that message, and once it gets delivered to that server, and the other one can consume these messages. So this helps message interaction between cross platforms to be very easy. So that's the reason why we need a JMS in a Java enterprise version, like integration of a Java EE application. So we might sometimes need these queues so that we can deliver these messages to these queues and someone else can consume the XMLs. So that is what is called as JMS. So we need JMS APIs in order to use these queues or send messages to these queues. So let's quickly see one example where we are actually sending a message to a queue. So here, so let's say we have a main program. So it can be a standalone, but in an enterprise application, you typically deploy it on a application server, whether it can be Tomcat or it might be WebLogic or WebSphere. So in that case, you will have a JNDA name. So we will see what a JNDA name is. So JNDA name means Java Naming and Directory Interface, which means you can actually store objects in a particular directory structure, so that when you request for that particular object, you get an object of that type. So for example, you can store a queue object in a JNDA directory, and you can get the destination, or you can get the queue details by just requesting the JNDA name. So we'll see what that is. So for example, we have a JMS context. So it can be any context, like someone asked me in one of the previous classes. So if the name should always match application context or not. No, it can be anything, but there is a way to actually load that context file. Use this new class path XML application context and give the path of that particular context file, and it will load whatever the beans are there inside that context file. So this can be application context or any context or any file.xml file, right? So but it needs to be have those beans declared so that we can use those bean IDs, right? So we how you get that bean? By the bean ID, you use the context and then use the method get bean. So it is the manual way of it's a programmatic way of getting the bean IDs, right? So unlike that, we have in Spring 3 version, so we can use that auto void annotation like in one of the examples that we have seen before. So all we are doing is we are using auto void annotation. So we will get this bean ID based on this annotation. So we don't have to use that get bean method. This annotation will automatically pull it from the application context.xml file, right? So how it will pull it, how it will know that will be there in the application context.xml file. In the web.xml, we define the application context .xml file here in the context param, right? So which means that we are telling Spring that all the application configuration is there, like all the bean configuration is there in the application start dot. So it can be anything, application Raghav, application Sai, or anything. So any name, load all the beans that starts with application context, and load all the beans with that particular name, right? So it will load it will load all the beans and store it in the Spring container, so that Spring will manage all those beans, and whenever we ask for that particular bean, it will inject it into our action class. So here mail service is a dependent class for our action class. So this is what is called as dependency injection, DI. So dependency, we are injecting this dependency during the runtime. So this is also called as inversion of control, like whether instead of this class actually initializing this, Spring is actually injecting this class reference into this object, right? That is what is called as dependency injection and inversion of control. So both these terms can be used like alternatively, like both of them are almost same, right? So we have so we can define, or we can manually load a context file from within any class. So this is a standalone, like it is not deployed on any server or anything, right? So it is just a main method, and we can have a standalone application that actually delivers a message to the queue, right? So if you observe here, what we are doing first is we are actually loading the configuration file, and then we are actually requesting for a bean with this ID. So this is the ID. So whatever you see inside the get bean method, so that is the ID of a class, or whatever we define inside the application context file, right? So let's say we defined JMS template here, right? So this bean will be injected into our application here, right? So this instance will be an instance of this particular class, right? So this is a part of Spring provides us with this JMS template through which we can actually send messages to a queue and also receive messages from a queue. So similarly, if you want to send a REST call, like a RESTful service, so you use a REST template, or you can have SOAP template if you want to use SOAP, if you want to send a SOAP message. So Spring provides all these templates, so which makes our life easier. By just using this template, we can use some methods of this API and just send whatever message you want to that particular destination queue, right? So here we have this bean ID. So this should always remain same. So the class should always be JMS template. So this name you can define whatever name you want for this ID, but this class should always be JMS template. And the property name, so what is this property? And this class, when Spring creates this class, it needs a property with the name connection factory, right? So a property inside this class with the name connection factory. So what should it refer to? It is a reference to pooled JMS connection factory, and again it refers to another class inside the. So whenever you see REF, it means it is referring to another class inside our application context, right? So here we are actually referring to this particular bean, which means, so this class has a property called connection factory. JMS template has a connection factory which is equal to this reference, means this class. It is like defining a student inside a college class. Let's say we have a college class inside which we have a private student is equal to new student, right? So think of this as a college class, and inside which we have a property called student, and the student is actually a new student, so of this type, right? And then it again in turn has another dependency called connection factory, and that actually refers to another object. So if you see here, all this is wiring. So Spring is actually wiring all the dependencies of each class. So we are actually wiring dependencies. So that's the beauty of using Spring. So if you have 3 dependencies, let's say we have a class 1 here, and then we have a dependency called pooled connection factory, and which has dependency called ActiveMQ connection factory. So all these dependencies are resolved by Spring during the runtime, and it finally gives me an object of JMS templates with all these properties populated, right? So that's how I got this JMS template. So by using this template now, so what it does is it created a message broker for me. Means we are now ready to send messages. So it basically created a message broker for me, right? So Spring created a message broker within our own JVM so that we can send messages and someone else can listen. So whoever registers to this particular queue, they can listen to these messages. Right? So this is a simple Spring API that allows you to send messages to a particular destination. So here we are using ActiveMQ since it is an open source free message broker service. In real projects, they might use ActiveMQ, or we have IBM MQ, some message broker, IBM WebSphere message broker. So all these are the paid softwares, so we need to pay for them in order to use those services. Unlike that, ActiveMQ is open source, so it creates a message broker. So what it will do is it will basically create a message broker for us, and using that we can send messages to a particular destination. So what is a destination? It is a queue name, right, inside our messaging server. So it's the name of a queue. So we send that message to that particular queue, and when we send it, so whoever listens to that queue, they can use this method called receive and give the destination name. Remember, whenever we are sending and whenever we are receiving, we are using the same destination name, so that if you send a message to the destination and someone else can receive the same message. So here we are using it in the same program, but someone else who writes another program in another server. Let's say Raghu, you are sending a message and I am consuming message in my my machine. If we both are in the same network, so I can basically listen to the same destination queue what you have sent, and I can receive the message. So and I can do whatever I want with that particular message here, right? So that is the purpose of creating queues and sending messages using JMS. So Spring is an abstraction, or it is an encapsulation of the actual JMS APIs. But if you want to do it in a Java way, then there are many JMS APIs that you have to use, so which are provided by Java. So by using those, you create a connection factory and then get the queue and send the message. But this is the simplest way, using a Spring to send a message to any queue, right? So you can send the JMS message. So you can go through any of examples to see how the JMS message is actually sent. So if you see here, you create a connection factory and you create a queue, and then you create a connection factory, and then you create a session. But everything here is being done by Spring for us. So it is creating a session, and it is say create a producer, and then you have to put a text message and say text here, and then use producer.send method. So this is the native JMS API that we are using here. If you see the imports, so they are all from the JavaX JMS package. So this is through pure Java code, but what Spring is doing is it is hiding all these implementation details, and it is providing you with the high level API so that you can use this API and just call this method convert and send. It will internally do the same thing. Basically, it will create all these connection factories and message producers, but everything is being done from in a declarative way, like from the application context.xml. So we have all these beans defined there, and it creates a destination object and it creates a template, and by using the template method you can actually send these messages, right? So that is what is JMS is used for, to send messages to queues and to listen to those queues and consume the messages, right? So any questions so far? You understand how we are using Spring here and for dependency injection? అర్థమవుతుందా రాఘవ్? చెప్పండి, అర్థం అవ్వకపోతే చెప్పండి, ఎందుకంటే మీరు ఇంకో 2-3 వీక్స్లో మ్యాక్సిమం మీ రెజ్యూమే ఆల్రెడీ రెడీగా ఉంది. ఒక ఇద్దరికి పంపించాం కూడా క్లయింట్స్కి యాక్చువల్లీ. వర్కౌట్ చేయండి. ఈరోజు ఏం చదవలేదు అన్నారు కదా, మేబీ యూ మైట్ బి లాగింగ్ బిహైండ్. సో tomorrow will be our last day.
Okay.
Utilize this time and try to spend as much time as you can. So maximum అయిపోయిందా మీది ఇంకా? సో MQ అంటే అది అర్థమైందా? యూస్ JMS, why we use JMS అని ఒక ఐడియా అయితే వచ్చింది కదా మీకు, ఎంటర్ప్రైజ్ లెవెల్లో ఎందుకు యూజ్ చేస్తుంది నేను. Okay. Let me know if you have any question. We'll move on to some other example. Let's see. Okay. All these are this is a sample application of structs, Spring, and a JPA example. So JPA, what JPA means is Java Persistence API. This is a specification, means it only provides some high level interfaces, so we need to have an implementation of those interfaces. So JPA and let's go ahead and see what service implementation does. So we have a service, so person service. So this is an interface which actually exposes all the methods that we can do on a person, right? Find by employee ID, find all employees, update a particular employee, delete a person, or save a person. So these are all the Java doc comments. So you should be, whenever you write a program or any method, it's a good practice to include these Java doc comments, right? So that what is the use of using these comments? So it will actually help us in generating these comments here. If you see, implements methods that enable interaction between a controller and a person, DAO. So whatever we define it in the doc, Java docs, so whoever uses your program, so they will understand the program better. So that's why it's a good practice to always have some Java documentation comments whenever you write a new interface or new method. So that when you just hover over this method, you can see remove the associated person record from the data repository or whatever you define it here. Right. So here what we are doing, this is a simple structs and Spring integration with JPA, where we actually created a service and we define all the methods. So this is just a skeleton of all the methods, and then we have an implementation that actually implements all these methods, right? So if you observe here, this is a Spring 3 application, right? So Spring 2.5 and above, like we have these annotations called at service, and at repository, at component, and at controller. So all these annotations we use to inject this particular implementation into any other action class. So this is same as defining this class as bean tag bean ID as person service, right? So this is similar to whatever if you use bean ID and use person what is that person service. So if you create a new bean with this ID and give this class as a class name there in here, so it is basically same as doing so we can achieve the same thing using annotations here, right? At service, and we define the bean ID inside the service tag. So what Spring does, whenever it sees this annotation, it will create a bean of this with this ID, and whenever we ask for that particular bean in our program, so here we are asking for that person service, right? So Spring will inject that person service object into this particular action class. So all is being done by Spring by using annotation. So you don't have to define it using a bean ID. So if you see anything with this at service or at controller, so it means we are creating a bean and we are telling Spring to manage this bean through the Spring container, right? So this is same as defining bean ID in the application context.xml. So we are actually extending this action support class, which we have to do in struts application, struts2 application, if you want to behave your class as an action class. And all we are doing is we are calling that service find all employees method, right? So it actually fetches all the employees and it will display it to the user. So here again, if you see, so DAO means data access object, so which is used to talk to the database. So it gets a step closer to the database. So person DAO, right? So if you go and see what the person DAO does, it actually implements this person DAO, inside which we have entity manager. So on the entity manager, we actually call named query or create query. So whenever we are using JPA and an implementation, so normally we use entity managers. So we have two different things. Whenever you use Hibernate, use the Hibernate session dot update or session dot save or update or session dot save, right? So similarly, we can have an entity manager. We just use entity manager create named query, and it will basically create this query and get the result. So all we are using here is an entity manager, which is which will be injected by Spring itself. See, if you see here, so there is an annotation called persistence context. So there are two ways. So one, we can have hibernate config.xml file. That is one way. So when we use hibernate, so we use that configuration file. So you might have some projects, you might see some projects where they are not using hibernate, where they might use hibernate, but if they are going persistence context, so you will have a persistence.xml file, right? So let's quickly go through that persistence.xml file. It will be there in the meta-inf folder always. So persistence.xml file. So what it carries now is, so it will have the persistence unit name, right? Spring JPA persistence unit. So this persistence unit, so is using Hibernate persistence provider. If you see here, org Hibernate EJB Hibernate persistence. So this, by using this class, so this is the actual implementation of all our database. So here you give all the database details, right? So we are using SQL, HSQL dialect and show SQL. So we can define all the properties in the persistence unit.xml file. Just like we have defined everything in the hibernate.cfg.xml file, so we can do the same thing in the persistence.xml file here. Right. So this is a typical application with the Spring JPA, Hibernate, and struts integration. So you can see the entity manager factory. All these beans are always common. So this is a one-time configuration that you need to do. So you don't have to worry about it now and then, but every now and then. But sometimes you might have to change these configuration files. But this is normally done at a project incubation time, like whenever we are actually creating a new project. So then we have to do all these configurations, like defining the entity manager factory, defining the persistence.xml file location. So this is a Spring way of doing or declaring the transaction management or the persistence management. So if you see here, so this always remains common, so you don't have to basically change any of these once you start on a project. But the main thing here is you need to understand, so what is persistence.xml file is used for. But once I send you this, I will send all these sample projects to you so that you can create and build it on your local machine and see how these things work. But for now, just know that this persistent.xml file is used to configure the database, and it will actually depend on application context file to actually create an instance of this entity manager, and that's how you are able to persist it. So once I give you this application, you can go through these and you can keep it as your reference. Even if you go to your future projects, you can always refer to these and see, okay, what an application context is used for and what is a persistence.xml. So it will give you an idea. So let me deploy this application and see what it is actually doing. So we will have another example for Spring AOP. So we will discuss that tomorrow, aspect oriented programming and why we need it. So that is a slightly complex topic. So that is used basically to deal with multiple concerns, so cross-cutting concerns in any application. So we will see that in tomorrow's class. So today we will see how this application works, and we have seen what is JMS and what are the Spring APIs to generate or to create a JMS message and send it to the queue, and how to consume it, right? So yeah, get familiar with all these annotations, because you'll see these a lot whenever you work on a Spring project, or if you work on a Struts project, you will see all these action classes a lot. So you extend action support and implement model driven. So whatever student, like whatever bean that you want to populate the information front end. Right? So all these controller, which means it tells Spring, so it will be a Spring managed bean now, this add student action. So controller is a Spring annotation which is actually used by Spring to load this into the Spring container, right? So please. Let's start this application and see what it is doing, and then we can debug and see what's going on. That's good. Okay, so what if you want to debug any application? So let's quickly run through this and see what's going on. So here the index page is actually providing me an interface to enter the employee ID and submit it so that it will save it in the database, right? So find all employees. If I click on find all employees, so what's happening? It is going and pulling all the information from the database, right? So let's quickly see what this find all employees is doing here, right? So now the quick start. All persons finder, right? So we have struts.xml file which has this mapping on what that click should do. Okay, so here all person finder, right? So this is the action of the index.jsp page where we have find all employees. I just clicked on find all employees, right? And it is linked to the action all persons finder, right? And once our application sees this action, it goes and inspects this struts.xml file, and it will point out what action we need to execute for this particular path. And then it goes into the all persons finder class and it executes the method with the name execute, right? And this is the result of, this is the return type of the method, of the execute method. If the return type is success, then go to the personsinfo.jsp page. That's what we are telling it to do. So here if you go and see what is the execute method is doing, it is actually just a second. So here what the execute method is doing is it is actually executing the service dot find all employees method, right? So we injected this person service using this person at service annotation, right? So that's how it got injected into our application and into our action class. So this is what is called as a dependency injection, right? So and then what we are doing, we are calling find all employees method on the person service, and this again has a dependency called person DAO. So here we are actually separating different layers. So one is service layer, so one is DAO layer. So DAO is one step closer to the database, so where we do all the database operations, right? So if you see, and in the DAO input here, actually we are getting the database entity manager and actually executing the actual query here inside the DAO. So if you separate each of these layers, so it will be easier to maintain, and as the application grows big, it will be easier for all the developers to maintain it, right? So if you put all of them, so you can so there are several ways of coding this. So you can basically put everything inside your action class, right? So everything like the control, the DAO, the service, and the entity manager or whatever. So you can put everything in one class, but that doesn't look good, and it won't be more reusable, or it will be a mess when the application grows bigger, right? So that's why you need to separate. You need to understand what are all these different tiers, like web tier, like front end, middle tiers, and service layers, and DAO, data access object layers, right? So in here, so it is very clean now, right? If you see this action class, so we have it looks like we are doing nothing, right? But actually we are doing a database operation, and we are using a service layer, and we are using Spring to inject all these beans, and there are a lot of things that are going on. But if someone sees this program, it seems very obvious, like it is very simple program. But once you go into the details, so if you separate these layers, then it will be very easy. So that's what we are doing here. Okay, so let's go and see what this find employees is doing. And it's again calling a data access object, find all employees method. And in here we actually have an entity manager, create query, and we are using a from. So whatever the name of the person that we want to query, and then it is actually giving me a result, right? So this is one way. Another way, rather than using Hibernate, you can use entity managers by using the Spring persistence context. So everything is being loaded by the application context here, right? So you can so here if you see we have an embedded database, so we don't have to create a database. It will create when the application loads. Spring creates a database and puts all this information in the persons table. But this won't be a good practice to do it in the production environment. So you will basically have a SQL or MySQL or DB2 or any other database connections defined here, so that we will get a connection in our entity manager or in our data access object. Right. See here we are using auto wired annotation, which actually injects this bean, right, from this implementation. So if you see here, so we have a repository bean name defined here, and that is being injected into the service layer using auto wired annotation, right? So the main thing to notice here is, so we are actually making all these dependencies. So we are managing all these dependencies by using Spring. So that's why if someone asks you why you need Spring in your project, then you should be able to answer like, if you want to manage dependencies, and if you don't want to load all these classes one time during the application startup, so it will basically bloat your application, right? If the number of classes goes big, then it will actually impact the performance and the application startup time. This is an example of Spring. So we can also use Spring for transaction management by using a transactional annotation of Spring. But if you're using transaction, you have to define some things in your application context.xml, where you specify transaction annotation driven. So this line, which actually makes your application transactional, right? So what transaction means is, so if someone calls this method, so that will actually begin a new transaction, and once you update this method, and the transaction will be ended. So all this will be taken care by the container, Spring container. So you don't have to worry about starting a transaction, begin transaction, and close a transaction. So you don't have to write those methods, right? So in one of our examples, so we have seen how we are actually writing transactions, right? So if you see here, we are actually beginning a transaction, and until and unless you begin a transaction, this won't be considered as a transaction, right? So, and then we are actually committing the transaction, and then we are ending the transaction. So but we are not doing that whenever we use Spring transactional support, right? So when we use Spring transactions, then all we have to do is use that transactional annotation, and that will take care of implementing the transactions. Right? So you don't have to begin a transaction and end a transaction or commit a transaction. So you can reduce those lines of code by actually Spring will put those lines of code in during the runtime when it sees this transactional annotation, right? So this is how you make a application transactional. So by using Spring transaction management. So if someone asks you how you manage the transactions by using Spring, so you should be able to answer by using a transactional attribute, right? So we can also have a transactional types attributes defined here. So isolation levels. So isolation. So red uncommitted, red committed. So we can define some of the attributes here itself when we define something. So which means that we can also define the isolation levels. So it means this method will only read the committed transactions. If someone else is doing some other transaction and if they haven't committed any of that stuff, it won't give us the expected results. So we can also define these isolation levels here. So the default transactional level is required. So just go through. I've asked you to go through the transactions and transaction attributes. If you have gone through, so you might be getting an idea on what a transaction is and how we use transactions. What is the use of transactions in a enterprise application, right? So this is very important. So Spring is one of the uses of Spring is we can actually manage transactions. The Spring container can open a transaction and commit a transaction. We just have to use this transactional annotation, and you have to mention in the application context.xml file that this application is transaction driven, right? So means annotation driven. Right, you can define the transaction manager, like who manages all these transactions. So you can also define the transaction manager. So if you are typically using a Spring transaction management, then you should be knowing all this stuff, and you should be familiar with what a transactional does. So if you happen to be working on any Spring application, then you will see this annotation a lot, which means that which is nothing but this method is a transaction based method, right? So you don't have to write a begin transaction, end transaction, commit transaction, roll back if something happens, and Spring will do everything for you, right? And we'll see Spring AOP, and we will go through Spring AOP and EJB in tomorrow's class, because it will be too much for today, because we covered. Hello?
Hello?
Yeah.
సార్ ఇప్పుడు అంటే స్ప్రింగ్స్ తోనే ట్రాన్సాక్షన్స్ మేనేజ్మెంట్ చేస్తే అంటే స్ప్రింగ్స్ ఈజేబీస్ ని రీప్లేస్ చేయొచ్చు అని చెప్పొచ్చు సార్ అంటే ఇప్పుడు
Yeah, in EJB, so EJB container will manage all those transactions. Means Tom E, like open source lo aithe meeku Tom E server recent ga release ayindi, which has an EJB container, which means it can manage the EJBs. But normally EJB containers are available as a they are proprietary softwares. If you have IBM WebSphere or WebLogic, they basically have these EJB containers. So if you want to EJB, then you have to go for these commercial products, so which have these EJB, which knows like how to manage these EJBs, right? But if you are using a Tomcat server, so which doesn't have an EJB or EJB container, so in that case you have to manage those transactions using Spring. So there is no other options to manage your transactions. So that's the reason why we are actually going for transaction management here. If you are using EJB, so then EJB container will take all the transaction management. So we can assign the EJB container the transaction management stuff. So if you see here, so there's something called as an EJB container in an application server, right? So if you see here, so this is an app server, which means in our case, let's say we have Tomcat, right? Our Tomcat doesn't have this EJB container. So that's why we cannot use EJBs to deploy it in our Tomcat. But Tom EE server, so which is Tom Enterprise Edition, that is also an open source server that has an EJB, that comes with an EJB container, and we can use that one if we are using EJBs. So that is an open source. And also if you are using IBM WebSphere application server, that contains EJB container, so it understands so what an EJB is and how to manage these EJB life cycles and how to manage transactions, right? So that is the main difference between EJB and using the Spring transaction management. Is that clear now?
ఓకే సార్ ఇంకొకటి జేఎంఎస్ లో ఇది మిడిల్ లెవెల్ ఉంది కదా సార్, ఇది అంటే మెసేజ్ బ్రోకర్ గానీ యాక్టివ్ ఎంక్యూ గానీ.
Yeah. That is the MOM enter, so message oriented middleware. So that
అంటే ఇప్పుడు అక్కడికి మనము ఓన్లీ మెసేజ్ పుష్ చేస్తే అంటే ఆ సర్వరే అంటే మెసేజ్ ఎక్కడికి పంపించాలన్నా సర్వరే చూసుకుంటారా సార్ ఇప్పుడు అక్కడ?
yeah, actually you have to define like the server has a queue name, right? So someone in some other program, they will register to that queue.
ఓకే
If you see here, so a MOM server will be in the middle layer anamata. This is that's why it is called as a middleware. So it is in between the client and is like publisher and the receiver. So we send the message to the MOM server, right? And then from that server, if someone registers, it will have a queue name in it. So we can define any number of queues inside a server, a message oriented middleware. This is called a message broker. So you can define any number of queues here, and you don't send the messages to the message server. At the end of the day, you will send it to the message server, but you directly send it to a queue which is registered on this server. So someone else, whoever is receiving that message, they will actually receive it based on the queue name. So they will say something like, okay, give me the messages of that particular queue. So then they will they will consume the messages. So if you have observed this example where we have seen one, so if you see this, so we are actually sending one to the destination. So this destination is a queue name. Okay. So that queue name we are sending this message.
Okay.
So that queue resides on the server, message broker server, and someone else, they have to call this particular line, which actually is receive and the destination name. This is the queue name. So they are basically trying to receive the messages whatever they get on the destination queue. So this is the way of receiving the messages, and this is the way of sending the messages. Okay. రాఘవ్, మీకు ఏం క్వశ్చన్స్ లేవా?
ఏం లేదు సార్ ఈరోజు.
బాగా అర్థమైనట్లుంది అయితే. ప్రాక్టీస్ చేయండి, శాంపుల్ ప్రోగ్రామ్స్ క్రియేట్ చేసి, సో ట్రై టు create programs on your own. So that's